Hello guys, welcome to Miss Billion's classroom. Today we are going to discuss about the layers of the Earth's atmosphere. So our objective for today is first, describe the layers of the atmosphere. Second, differentiate the layers of the atmosphere based on the variation of temperature. And then letter C is to explain the significance of the layers of the boundaries between them. So are you excited? Okay, let's go. So atmosphere is a layer of gases. So what are the gases that we can see or that we have in the atmosphere? The most abundant is our nitrogen. As you can see in the chart, there is 78.1% of nitrogen gas in the atmosphere. Next in line is the oxygen, which is 20.9%. And then next we have the argon, which is 0.9%. And then we have the carbon dioxide, which is 0.035%, and the other gases, which is 0.065%. What are those other gases? So we have the neon, helium, krypton, hydrogen, xenon, ozone, and radon. So as you can see in this chart, so the blue one means it is the nitrogen. So as you can see, this is like what I've said, this is the most abundant gas we have in the atmosphere. And then the red one here is your oxygen. And as you can see in this pie chart, there are very little and very small amount of other gases. All right? So what are the layers of the Earth's atmosphere? So let us start from the top to bottom. So we have the thermosphere, and then we have the mesosphere, stratosphere, and troposphere. So you have seen here mesopause, stratopause, tropopause. So what are these? These are the boundary of each layer. So we will see as we continue this discussion. So you have seen here the troposphere. Next is the stratosphere, mesosphere, thermosphere, and exosphere. As you try to notice, I did not put exosphere here. Later, you will know why. Okay, so as you can see, I have here a chart. So in this chart, this x-axis is the temperature, all right? And then this y-axis is the height. So our zero temperature is right here. So we will talk about this graph every time we discuss about the layers. So let us start. Let us have first the troposphere. The troposphere is the most closest to the Earth. So this is the lowest and thinnest layer. So it is 16 kilometers at equator and 8 kilometers at poles. So 90% of the atmosphere's mass is the troposphere. So as you can see here, the temperature decreases with the altitude. So the temperature decrease with the height. So there is 6 degrees Celsius per kilometer. So every time it increase the altitude or the height, there is 6 degrees Celsius difference. So the top of troposphere averages, and it is negative 50 degrees Celsius. So this is also where the weather occurs. So when it rains, when it snows, this is where it happens. So the boundary between the troposphere and the stratosphere is what we call stratophos. Okay, or tropopause. Sorry about that. So that is what we call tropopause. Again, the boundary between the stratosphere and the troposphere is the tropopause. Okay, so as you can see in here, this is your troposphere. Okay, so from negative 10, let us say negative 10 degrees Celsius, as it increases the altitude, also the temperature, what happened, decreases. Okay, it decreases, it going to the left, it is going to the left. So if it is going to the left, therefore the temperature decreases as you try to remember your number line. Okay, so before we proceed with the stratosphere, I want you to watch this journey to the stratosphere. So if you want to continue your approach, starting formation reporting. Oh, that's so smooth. I've gone upside down. 150. That's unbelievable. When we're heading 150, like you said. It's beautiful there. The clouds are just stunning the way they wrap their way around the Table Mountain.
The atmosphere that surrounds our planet is made up of 4 key layers, each very different. Although I'm above the clouds, I'm still at the very bottom, in a layer called the troposphere. It's a narrow band, usually little more than 10 kilometers thick. The troposphere is a rich soup of warm, moist, oxygen-rich air. It's unstable, chaotic, and unpredictable, but life depends upon it. And in just a couple of minutes, I'll be leaving it behind.
So this is the high-tech jumbo jets cruise. Oh, yeah. Oh.
I'm now at 40,000 feet above the Earth. That's about 12 kilometers.
The pressure is less than 20% of what it is in the ground. And the temperature at minus 60 degrees centigrade. Just a bit high and at low pressure. That means that my body fluids would boil a day in seconds. So I'm pretty glad to be in here. Okay, you ready to go supersonic? Okay, here we go. We're about to go supersonic. I'm going to be Mach 1 emoji. Oh, that was a G-spot.
We're approaching 45,000 feet, and we're about to cross an invisible boundary in the atmosphere. We're leaving behind the first layer, the troposphere, and entering the stratosphere. A very different place. Here, the air is stable and exceptionally dry, so there's virtually no weather. The stratosphere is home to the ozone layer, which reduces the amount of lethal solar radiation reaching the Earth. We've reached 50,000 feet, or 15 kilometers. Nearly 90% of the gases that make up the atmosphere are below me.
Absolutely nothing above me. Black sky. Black sky, well, dark blue. Yeah. This is the highest I've ever been.
But the atmosphere stretches on high above me. It gradually fades away into space, which which is another 85 kilometers above my head. This is as high as this plane can take me. The return to Earth is even quicker than the journey up. Although my return to reality takes a little longer.
Terra firma, eh? Fantastic. It looks different from here. Oh, yes.
Okay. There you have it. So, what can you say about this video? Amazing, right? So, stratosphere. Stratosphere extends from 10 kilometers to 50 kilometers above the ground. So, meaning they are less dense and they are less water vapor. So, in here, temperature increases with altitude. So, as you try to remember troposphere, the temperature decreases with altitude. But this time, stratosphere, temperature increases with the altitude, meaning it is hot in stratosphere. So absolutely there is no weather occurrence in the stratosphere. So stratosphere is where ozone layer can be found. This is the location of the ozone layer. And then the upper boundary of the stratosphere, or the one that divides the stratosphere and the next layer, which is mesosphere, is what we call stratopost. So like what I've said, as the temperature increases, the altitude also increases. So as you can see from here, which is the troposphere, so the temperature decreases with an altitude, right? So meaning it's cold in here. But as we go to the stratosphere, what happened to the temperature? It goes higher, meaning it becomes hot in the stratosphere. So this is, what is this? This is the clouds. So in here, as you can see, this is the Earth, all right, and this is the troposphere, or the tropospheric ozone, which is from 0 to 9 or 17 kilometers, and then the stratosphere and the natural protective ozone layer, which is 17 to 50 kilometers. You all know, guys, that ozone layer is the one that um, protects the earth from the sun. All right, next layer is the mesosphere. So the mesosphere extends to almost 80 kilometers high. 80 kilometers high. So gases are less dense in here, and the temperature decreases as altitude increases. So if that happens, meaning what kind of temperature do we have in here? Is it hot or cold? It is cold because the temperature decreases as altitude increases. So gases in this layer absorb very little UV radiation. So like what I've said, the temperature decreases as the altitude increases. So this is your mesopause. So mesosphere, it's becoming cold. Imagine, so from negative 80 degrees, negative 100 degrees, it is super cold in here. All right. Next is the thermosphere. The thermosphere, it is above the mesosphere and extends to almost 600 kilometer high. So the temperature increases with altitude. So if the temperature increases, therefore the temperature is hot or cold. Yes, it is hot. So it readily absorbs solar radiation. So temperature can go as high as 1500 degrees Celsius. Imagine that. That is so hot. So it reflects radio waves in here. So meaning the satellites can be also found in thermosphere. So like what I've said, the temperature increases as the altitude increases. So the temperature change with height. Okay, so now are you excited to see one of the greatest thing that you can see in thermosphere? Okay, let me show you the aurora borealis. So this is how aurora borealis looks like. Later I'm going to show you a video. But before that, let us discuss first the exosphere. The exosphere is the interface between Earth and space. So meaning it is the one that divides the Earth from the space. So atoms and molecules can escape to space. So as you can see, there is a word ionosphere here. Ionosphere is um, is a layer of the Earth or the atmosphere that has ions. Basically, magnetosphere is also or can also be found in here. So ions means charged particles. All right. Okay. So structure of the atmosphere. So atmospheric ozone is good ozone. So like what I have said earlier, stratosphere is where ozone can be found. So it protects Earth from the harmful UV radiation. Also, depletion is detrimental to life. It can be we can die with depletion of ozone layer. So tropospheric ozone is bad ozone. In the troposphere, ozone is a pollutant. All right. So we don't want ozone in the troposphere. We just want ozone in the stratosphere. So another example of pollutant is CFC, chlorofluorocarbon. Okay. So what is ozone? Okay, let me show you what is ozone by watching this video. Oops, I'm sorry about that.
Ozone is a form of oxygen. An ozone molecule consists of 3 oxygen atoms. An ordinary oxygen gas molecule has 2 oxygen atoms. Most ozone is found in the upper atmosphere, where it is produced in small amounts, when the sun's high-energy rays strike ordinary oxygen molecules. The ozone molecules in the upper atmosphere absorb most of the sun's harmful ultraviolet rays before they reach the Earth. These rays can cause skin cancer and other health problems. A group of gases called chlorofluorocarbons, or CFCs, may pose a threat to the ozone layer. Chlorofluorocarbons are chemical compounds made up of atoms of chlorine, fluorine, and carbon. CFCs are used as refrigerants and to make plastic foam insulation. Because they are gases, CFCs can escape from poorly sealed containers into the atmosphere. Once CFCs are in the upper atmosphere, scientists believe a chain of reactions occur that destroy ozone. First, high-energy ultraviolet rays break chlorine atoms free from the CFC molecule. These free chlorine atoms can react with other molecules in the atmosphere. When a chlorine atom reacts with an ozone molecule, it steals one of the ozone molecule's 3 oxygen atoms, forming a molecule of chlorine monoxide. The remaining 2 oxygen atoms form an ordinary oxygen molecule. In this way, an ozone molecule is destroyed. Chlorine monoxide reacts easily with single oxygen atoms in the atmosphere, leaving a free chlorine atom that can destroy more ozone. Scientists estimate that one chlorine atom can destroy as many as 100,000 ozone molecules.
There you are. So imagine how harmful is the ozone when it goes to the troposphere. All right. So ozone depletion, the main cause is the CFC pollution, as you also watch from the video. So radiation from the sun causes the CFCs to break down. So this chlorofluorocarbon, so it is composed of chlorine, fluorine, and carbon. So what happened is it releases one chlorine atom. So this chlorine atom reacts with oxygen molecules that forms chlorine oxide and oxygen gas. So what happened? There will be global warming. There's an increase in Earth's average surface temperature caused by an increase in greenhouse gases. It is also caused by greenhouse effect. So if there is global warming, meaning it will be very, very hot. So imagine if you are walking the street with your ice cream. If it's too hot, the ice cream would be melt right away. You know what I mean? So greenhouse effect, the trapping of heat by gases in the atmosphere. So these are the greenhouse gases. So we have the carbon dioxide, sulfur dioxide, ozone, CFCs, water vapor. So what happened? The solar radiation enters in here on the earth, and then it will get all those CFCs, and then we'll get back to bounce back um, to the universe, right? So effects of greenhouse gas pollution. So global warming, ice and polar caps will begin to melt. Imagine poor polar bear if they don't have those polar caps anymore. Water in the ocean expands. Flooding in lowlands and coastal areas, changes in weather plans or patterns. So now I have, as I have told you earlier, I'm gonna show you the aurora borealis. How does it look like? So I myself, I haven't seen the aurora borealis. That's why I wanna see, or I wanna go um to the like Iceland, where you can see the aurora borealis or the northern lights. So look how wonderful and amazing it is. What happened? You see, they have different colors. This is a time lapse of the northern lights. Wow. Wow, that is so amazing. So, I hope you learned something today. To wrap up the lesson, I will play the song of Mr. Parr. If you are familiar with Mr. Parr, oh, you will love him so much. All my students from the past, they love Mr. Parr. So, are you ready? Okay, listen to the song.
This layer has all the clouds. Troposphere life will be found. Sun warms the ocean and ground. I'll tell you, breathable gases in here. Warm sun radiates, this layer gets cold as you move up above, as it turns to the next layer. The atmosphere is why there's life, because the raging suns of fire in the sky. Thanks to the ozone, rays are absorbed of the sun. Stratosphere, here we come. Planes fly there to and fro. The ozone layer is among. It's got ozone really so neat, blocking some rays like UV. It rises up like a tide. The temperature it will rise. The atmosphere is why there's life, because the raging suns of fire in the sky. Thanks to the ozone, rays are absorbed of the sun. Mesosphere is cold. Meteors will glow molten, and all your fears will subside. All the meteors will fry. Ionospheres on the list, aurora borealis, and the exosphere will disperse. The hottest layer, of course. The atmosphere is why there's life, because the raging suns of fire in the sky. Thanks to the ozone, rays are absorbed in the sun. Thanks to the ozone, rays are absorbed in the sun. Yes, rays are absorbed in the sun.
There you have it. I hope you've learned something today. All right, thanks, guys. Bye.